Hello everyone. In today's video we're going to start with some terminology. Particularly in this video we're going to discuss about random experiment, outcomes and events. A random experiment is a process leading to or more possible outcomes without knowing exactly which outcome will occur. For example, a coin is tossed and the outcome is either a head or tail. A company has a possibility of receiving from 0 to 5 contract awards. Or the third example is a customer enters a store and either purchases a shirt or does not. A sample space, typically denoted by S, by letter S, and it is the possible outcomes from a random experiment, which is called a basic outcomes, and the set of all basic outcomes is called a sample space. An event, typically denoted by E, by capital letter E, is defined as any subset of basic outcomes from the sample space. An event occurs if the random experiment results in one of its constituent basic outcomes. The null event represents the absence of basic outcome and is denoted by big letter O crossed out with a line. Okay. What do we mean by intersection of events? Let we have any two events, uh, events A and B, right, in a sample space S. Their intersection, which is denoted by letter U, upside down, so to speak, is a set of all basic outcomes in S that belongs to both A and B. Hence, the intersection A and B occurs if and only if both A and B occur. We use the term joint probability of A and B to denote the probability of intersection of A and B. But also we can have general cases. For example, given k events, for example, E1, E2, and so on and so forth, Ek, and their intersection, E1 intersects E2, intersects E3, and so on, intersects Ek, is a set of all basic outcomes that belong to every Ei, where I starts from 1 and finishes with k, from 1 to k. Also, in a course of probability theory, you might face with a term called mutually exclusive. And for example, if the events A and B have no common basic outcomes, they are called mutually exclusive. And their intersection, A intersects B, is said to be empty set, indicating that A intersects B has no members. For example, you can see on a diagram in the second case, for example, here, these two sets A and B said to be mutually exclusive. And the last one is union. Let two events A and B, the event B to be the events in the sample space S, and their union denoted by A union B is a set of all basic outcomes in S that belongs to at least, this is a crucial point, at least one of the two events. Okay. Hence the union A and B occurs if and only if either A or B or both occur. And of course we have a general case for k events. Given the k events, for example E1, E2, and so on, Ek, their union E1 unions E2, union E3, and so on, union Ek is a set of all basic outcomes belonging to at least one of the key events. And you also can see the diagram below. So as it says at least one of the two events, so either event A or B or its intersection. And what do we mean by collectively exhaustive? Given the k events E1, E2, and so on, Ek in the sample space S, if E1 union E2 and so on union EK equals to S or constitutes our sample space, right? These K events are said to be collectively exhaustive. Um, and of course, in probability theory, you might face the term complement, and complement is defined in the following way. Let A be the event in the sample space S. The set of basic outcomes of random experiment belonging to S but not to A is called complement of A and is denoted by A. So some problems. Let's start with the problem number 3.1. So we are given a sample space of E1, E2, E3, and so on, E10, and we need to find complement of A, right? Complement of A means everything that lies beyond or outside of event A. So in event A we have E1. Therefore, for complement of A we will have E2. In event A we have E3 and we don't have E4 and E5. Therefore, we will have it here, E5. For even A, we have E6, but we don't have E7 and E8. Therefore, we will have its complement. So basically, we're done. So remember, E complement is everything that lies outside of event A. Let's solve 3.2. So we are given that A consists of E1, E2, sorry, E3, E7, E9, and we're also given event B, E2, E3, E8, E9. Now, what is the intersection A and B? So we are looking for common elements. So clearly we can see that E3, it is only, not only, sorry, these two events are two common elements of both sets. Now, let's find what is the union of A and B. So we need to list everything in event A and everything in event B. So we can cross it out because it's a duplicate, right? And the last problem is the union A and B collectively exhaustive? So to be collectively exhausted, we need to have so E1, E2, and so on, for example, EK needs to construct our sample space. However, in our sample space, we see the elements which are not in the union. Therefore, we say thus, no, the union A and B is not collectively exhaustive. So again, as I said, our union A and B is consists of the following elements: E3, we don't have E4, we have E7, E8, E9. So if we compare our set sample space S, it has every element from E1 to E10, and we are missing E4, E5, E6, and E10, and therefore it is not collectively exhaustive.